Concept getters, welcome back again to the third part of solving exponential equations. Okay, this what I'm doing. What am I doing now? I'm not on radio. I'm on YouTube, for crying out loud. Anyway, concept getters. This is the third part, the part 3 of solving exponential equations, right? And with this one now, remember the first one I said you just simplify, right? The second one, if you remember very well, I said you just separate the two exponents because it's just two terms on the exponent, and then the x, the variable in the exponent, does not have a coefficient. Now, when you look at this specific one, the variable on the exponent, it has a what? It has a coefficient. You can see here we have a 2x. The minute you see your variable on the exponent having a coefficient, right, and then you see another term with the base, the same base with a variable that doesn't have a coefficient, and you have a third term, oh, my voice is changing, then you know that you have to introduce what we call K method, substitution method. You're going to substitute something. But first, let me highlight something. Guys, according to the laws of exponents, right? When you have something of this kind, if you have 2 to the exponent 3 all to the exponent 2, right? This is the same as 2 to the exponent 3 times 2. Basically, they will multiply each other, right? And then if I swap them, if I say 2 to the exponent 2 times 3, whether it's 3 times 2 or 2 times 3, it is the same thing. And then if I close the bracket just between 2 and 3 and just say 2 to the exponent 2 all to the exponent 3, this will lead me to this, basically, because 2 squared, which is 4 to the exponent 3, will do that make sense? It's still the same thing as 2 cubed all squared. So if I just go straight to saying, when I see 3 inside and 2 outside, I can just put 2 inside and 3 outside. Basically, I've applied all these rules, right? Basically, I can say 2 to the exponent what? 2, 3 outside. So I can just swap there. Why am I saying this, guys? I'm saying when you have 2x, right, on the exponent there on the question, I can just swap x and 2 and then close the bracket between 2 and x. That's the first step that I'm going to do. You know why? I want this base here to be the same as this base, and I want the exponent as well to be the same, and the 2 to go out so that I can let k to be 3 to the exponent x. So let me show you. Basically, my first step is just to swap 2 and x and then close the bracket between 2 and x. That's the trick part, guys. You're just going to say 3 to the exponent x close squared. That's the first step. The minute you see 2x, just go like, oh, 3 to the exponent x, 2 outside. Right? When you see 2x, just take the 2 and say 2 outside. And you're going to say minus 7 multiplied by 3 to the exponent x. You can bracket it as well. And then you're going to say equals to 18. Do that make sense? That's the trick part. From here on, you're going to be like, let k to be 3 to the exponent x, so that it can be turned into a quadratic equation. So let me show you. Where you see 3 to the exponent x, you're going to substitute by k. So let's do it. It's going to be k squared, right? Minus 7k. And then I will transpose 18, I'll say, and say minus 18 is equals to 0. Now I can factorize, right? I'll just say v2 equals to 0, and then k, and then k, 18 factors of 18, that can give me negative 7. It's going to be 9 and 2, right? So I'll just say 9 and 2. And then to get a negative, the bigger number has to be negative and the small one positive. Then I'll say k minus 9 is equals to 0, or k plus 2 is equals to 0. Zero factor theorem, right? And then now I'll just transpose and say k is equals to 9, or k is equals to negative 2. But guys, now remember, they did not want us to solve for k. On the question, they said solve for x, right? Solve for x, guys, solve for x. So which means I have to substitute back my k with or by 3 to the exponent x. So I'll just say 3 to the exponent x is equals to 9, or 3 to the exponent x is equals to negative 2. But we all know that a base being raised to an exponent of a variable, and when the base is not like there's no negative sign before the power, just know that there's no way the answer will yield a negative answer. You can try on your calculator, substitute x with any value of your choice. The answer can never be negative. Do that make sense? Which means with this part, just go like it's not equal to. Which means this one is like it's not applicable. You can write NA if you want. You can say NA, right? And you'll be left with 3 to the exponent x equals to 9. Now I will continue this here, right? I'll just say when you have 3 to the exponent, when you have 3 to the exponent x is equals to 9, 9 can be changed to what? To 3 to the exponent 2. So I'll say 3x, 3 to the exponent x equals to 3 to the exponent 2. Remember, when the bases are the same, you can equate the exponent. So you just say x is equals to 2. And yippee, we got our solution. So guys, with this one, remember, when the coefficient of the exponent, which is x, the x, coefficient of x on the exponent, if the coefficient is 2, and there's another term that consists of the same base with the same variable, right? Just note that this one will lead you to a quadratic. Therefore, you have to use the substitution method, the K method, right? Which means you'll just say let K be this one. Do that make sense? And then you just substitute by K. You're going to swap 2 and x. You swap 2 and x, right? And then the 2 will be outside the bracket. And then whatever that you let K to be, you just substitute by K, solve it as a quadratic, and then solve for K. Then put back your 3 to the exponent x, right? Your power. And then the one that yielded a negative is not applicable. But if nothing yielded negative, they are both positive, you can solve both. Do that make sense? And then that's it. So you see now, with these 3 types of exponential equations, the first one, it just wants you to simplify. Just simplify one part, simplify the other part. You will have the same basis on either side of the equal sign, equate them. The second type is that you're going to have 2 terms on the exponent, right? 2 terms on the exponent, you just separate them, right? And then you take out a power that is a common factor, and then you divide by what's inside the bracket on either side of the equal sign, right? And then you'll have the same base. You can change the other side so that you can have the same base on either side of the equal sign, and then equate the exponent. With this one, you're going to have a coefficient of x on the exponent. You just swap 2 and that x, right? The 2 will be outside the bracket. And then the power inside the bracket will be what you will let K to be. And then it's going to be a quadratic equation. You solve for it, and then you take it back, right? The power, you substitute your power back to K, and then you solve for the exponent, which is the x, which was what the question required of you. Guys, don't tell me exponential equations are not easy from here on. But as you are busy saying, remember to also do this. How? Do this, right? Do what? Remember to subscribe so that you don't miss out on other simple concept, right? And share with others, guys. We want others to pass, right? And then remember to comment and like, engage, tell me what you would like me to simplify, and then so that you can help the algorithm to push this video to other students so that other students can also pass math like you. But most importantly, guys, with a smile, remember to pray for my handwriting. Ish.